morning, everybody. Thank you for being here for the panel on Cooler Than Crypto. We're lucky to have a few awesome people here that definitely know the space better than most. First up, we've got Irene from Bitmain. Next up, we've got Gerald from HM Tech. And then after that, we've got Taylor from CleanSpark. And I think that's it that made it this morning.
Get some attrition. Sure. Yeah.
Oh. So, format of the discussion, we've got 5 questions that each panelist will go through. Oh, wait. We've got another one. Fog Hash is here. Grab a seat. Thank you. Great that you made it. So we've got 5 questions that we'll go through. Each panelist will have the ability to answer. 2 to 3 minutes. We've got 60 minutes total. Probably won't hit 60 minutes, but after the 5 questions, we'll open up to Q&A, and then we'll wrap this up and we'll get some coffee. So first question up is, in your opinions, is the ROI really there for immersion hydro infrastructure as an investment for digital mining? Irene, kick it away.
Thank you. I'm Irene from Bitmain, and from my perspective, we have our hydro cooling infrastructures, and we actually successfully work with some of our clients in the different regions to deploy it, and it's actually have a really good ROI. So to answer your question directly, yes. It's not only about the technologies, this stabilization, but also we are offering some flexible terms for them to support their expansion with the hydro cooling technology in different areas of the world. First of all, when we are talking to our clients since last year that if they have a site and they have interest to develop the hydro cooling technologies on the site, we actually support them with a series of solutions and projects. So it's still there. So if anyone have interest to deploy with their new mining expansion sites, we're happy to discuss, and everybody's very welcome to come to our stage, to come to our booth, and our BDs will share with you with the details.
So I think when we look at the ROI calculation on hydro and immersion, there's a lot of stuff to look at. And one of the turnoffs is obviously cost per T is a little bit higher than air-cooled. And I think some folks take the shortcut and they stay with the air-cooled. However, when you look at the longevity of the machines, as well as the uptime benefit that you're going to get, it significantly outweighs air-cooled. And that's kind of what we talked about yesterday, where there's a divergence forming, where you're going to have folks that do pay the higher CapEx to get immersion, that get hydro cooling solutions. And what they're seeing is that the number of touches that they need, the number of full-time employees they need, all goes down dramatically. And we're not talking about a small amount. We're talking 75, 80% less touches. When you have these hydro and immersion systems, they don't even need reboots. They just run. It's absolutely amazing. And what that does is drive your ROI higher. And then the lifespan of the machines is significantly longer. When they're dunked in the immersion fluid, or they're running in a sealed hydro system, there's no dust, there's no excess heat, humidity, bugs, all the nasty stuff that gets in there and kills the miners that we're used to seeing. It doesn't exist with the new hardware. So short answer is yes, absolutely.
Yeah, just to tack onto that, right? I think one thing that we don't talk a lot about in this industry is the fact that computers were never supposed to be ran outside in pods or in buildings with low filtration, no humidity control, no air conditioning, right? If you look at the typical data center industry, it's temperature controlled, humidity controlled. extreme amount of filtration, right? And so a lot of people don't like to talk about the failures in air from the bugs, the dirt, the heat, everything like that. And while immersion is a little bit more expensive on the CapEx side to outlay, the environment in which the miners sit in is a lot more applicable to a typical data center, right? And with those improvements in environment, you see a reduction in chip temperatures, you see an increase in lifespan. You can also use firmware to extract a lot more performance and or efficiency out of the miners. The way that immersion pulls heat from the chips, the boards, the hash cards, the controller is a lot more uniform, it's a lot more efficient, and therefore drives everything in a lot more controlled manner. So I think the ROI is there, not only from the aspect of the reduced parts, reduced labor, the overclocking, everything like that, but you're just providing a lot better environment in which the miners are sitting in.
Thank you for having me here. I'm Paulie from for caching. I think the future is coming. Either immersion cooling and or hydro cooling. Inevitably, is the future technology and trend in this industry because obviously it brings higher stability, efficiency, and it can combine with different application scenarios. But it's just a start. So we have to deal with a lot of challenges right now, like the capex, like the maintenance. So the industry has not been ready for the transition. It's just a start, but that's a reason why we should collaborate together to solve all the issues one by one. It's not only a technology, technology transition, but also the industrial chain. So it needs the effort of all the participants to build this ecosystem. Yeah, thank you.
Appreciate that, Paul. So potentially 75% reduction in OpEx, which is massive on an FTE basis. That's incredible. Stability of operations in different environments and different temperature gradients that you can now manage. That's obviously extremely important for operations and hash rate generation. To go back to you, Paul, we'll start on that side. How does your team view automation when you're deploying immersion or hydro type solutions for infrastructure?
The automation, so I think it's really important. Currently, one of the challenge is those systems are separated. They have no tight integration. So the cooling system, the mining system, the hash rate management, the site management, they are separate. So sometimes combined with the different scenarios like curtailment or heat reuse, you have to make full use of the hash rate or the power, or sometimes when the power price goes up, you have to do the curtailment. So that has to be done by the automation, by the fine tuning, by the connection with different parts, subsystems. So I think it's really important, but we just have a start. And yesterday I talked to its miner, the software management platform. We talk about how to provide APIs from different subsystems and do the integration. So yeah, I think so. Thank you.
Taylor?
Yeah, no, automation is everything at scale, right? You deploy your first megawatt, you can definitely kind of just handle your way through it, right, with a bunch of people. But once you get it north of 50, 60, 70,000, 80 machines, right, automation is literally the cornerstone of your business, from deployments, making sure that they're rapid, to energy curtailment, to making sure that you're not running through bad hours if you're operating in an open power market, to, you know, overclocking and making sure you're extracting the most, you know, terahashes out of your machine given any situation. So automation is key, whether it's in immersion or if it's in, you know, air-cooled. I think one really cool thing about immersion with the automation is really reducing the energy costs of your dry coolers and everything that is running your situation. And it's also a really good idea to keep your immersion set up, whether it's in the summer or in the winter, at like a uniform temperature, right? So we talk about why these machines last longer. It's not only because they're operating at a lower chip temperature, but it's also because they're in a lot more stable environment. The number one cause of chip failure is obviously dust and heat, but it's followed by, you know, the expansion and contraction of the chips getting hot and cold, hot and cold, hot and cold. And if you're able to use automation not only to get around, you know, power curtailment, overclocking and things like that, but you can actually use it to extend the lifespan of your machine by keeping the temperatures really uniform throughout the year and just giving the miners a really stable environment, like I said earlier.
Makes sense.
Cool. Yeah, we've got to spend some more time together. We're definitely aligned on a lot of this stuff, which I appreciate. So one of the things I really want to call out in regards to automation is the MicroBT and HeatCore team when they designed the current hydro containers that they're running. So it's fully automated. So once we do the setup and the machines are deployed, we literally set the dry core in auto mode where we say, hey, this is the temperature, the tolerance that we want for inlet and outlet water temp. The machines we can then tune, max power capacity, set the frequency, and then there's automation involved in the water pressure and water flow. Once you hit start, you literally walk away. You know, coming from, you know, traditional Bitcoin mining, you know, since 2012 with the air cooled, this is like a dream come true because, you know, you spend tons of money on your staff and doing reboots and babysitting these machines, and it's like there's always something going on. With the level of automation that's coming with hydro and immersion, it's going to completely upend the industry and how we look at our planning for ROIs on large facilities.
That makes sense.
Thank you. So we're actually very excited to see a lot of our clients have a strong software team, and they have their mining farm management software already applied automation in their mining farms. But with the liquid cooling technologies and plus the automations, I think it will be dramatically increase the effectiveness of their mining and as well as profit. We've been talking to several clients about how they work with their softwares, and we keep got feedback from them to improve, and make it easy for them to work with the miners to apply the technology and to be as easy as possible as everybody's talking about curtailment, and everybody's trying to save more energies, especially during the heat period time during the day in the summer. So I feel like immersion cooling system or just liquid cooling system plus the automation technology is really helpful for the entire industry to move to next level. It's decrease the operation cost for miners, and it also make our work and our clients' work easier on the side.
I appreciate that. So here's an opportunity to get some interesting stories from the battlefield of technology. I guess we'll start with Taylor, but we'll go through each panelist as well. Are there any interesting stories or lessons learned or battle scars earned in your team's exploration and use of the technology?
No, yeah, I mean, I think everybody has heard the horror stories of immersion trying to get through the thing. I think the advice I'd give to everybody is pre-planning, right, and obviously spending a little bit more money up front. We've definitely seen, I guess I'll go back to my previous role and seeing some of the problems of fixing other people's immersion setups, to keep it simple, right? Dry coolers aren't going to work in the middle of the summer in Texas. You need some sort of water, right? I think is a big one. Properly sizing pumps and then having an understanding of like how the electrical system's all going to tie together. And and all of that. I don't want to share anybody's horror stories, but you learn a lot of things along the way. I think that one of the big things is not reinventing the wheel. Like there's lots of things that are out there that are used in other industries that we can reuse in immersion to keep costs down, right? And yeah, I think that's a big one is not trying to push the envelope and making sure that you have just a full understanding of your system from start to finish, really. And I think a big one too is when we get into the two-phase question, right? I think that's where a lot of the horror stories and things that will come up. That's a lot more complicated if people are having struggles running single-phase systems. Two-phase systems, we'll definitely give them a run for their money. But yeah, I think that's where I'll go with that one.
Paul, you want to take this one next?
Maybe later.
Okay.
So I think the easiest answer to that, there's tons of horror stories about immersion and the systems that we all tried to create, because we're all innovators, right? So as this technology was born and it's matured over the years, we've all tried to figure out how to do stuff, and we've got enough experience and folks in this space that know how to get it done. Don't try to go on your own is the biggest advice I can give, because the CapEx to deploy hydro and immersion is higher. Like, don't waste your money. Just ask. Like, the community is pretty open to sharing data and sharing information on how we do things and how we've had successes. So don't try to reinvent the wheel, and just ask for help. I think we're all here to help each other out.
Yeah. Just to add on to that, I think a clear-cut one is don't try and make your own fluid. Like that one comes over. People try and sell me a proprietary fluid every single week, right? Just pick a provider. There's tons of good providers out there these days. There's two in the house today, both Engineered Fluid and Shell. I've deployed tens of megawatts of both of them. They both perform phenomenally. There's absolutely no benefit in saving $1 a gallon to test against tens of millions of dollars of machines that you're going to be put in fluid, right? There's also a lot of good tank providers out there these days, right? Do your research, do your homework, and go with somebody who's deployed 10, 20, 30, 40 megawatts, right? That you can call on their customers. They'll give you free-flowing data, to his point, right? If you have a tank provider or a fluid provider, pump provider, dry cooler provider that won't give you access to their customers, that won't give you clear-cut data on how their systems performs, that's a major red flag. Work with somebody else. I can tell you that there are plenty of providers out there that will give you that clarity. And the other big part is once you're deployed, if you're not an immersion expert, you don't have an immersion expert on your team, utilize the tank companies, utilize the fluid companies. They want you to be successful. They want you to buy more tanks. They want you to buy more fluid, et cetera. So really rely on the industry leaders and the people that have deployed tens of megawatts, so that way you're not destroying your first 5 megawatts, having a bad experience of going back to air cooling and not really innovating, right? We've had some really bad stories that have come out about immersion, a lot of them around one provider, which has provided a huge cloak on the industry, right? And I think if we can get some more positive stories and people can rely on the experts that have been out there and kind of proven their work, we'll get a lot more positive energy around not only hydro but immersion, and then we'll see a lot more advancements and hopefully a lot more innovation like we saw through 15 to 17.
Appreciate that. Irene, what kind of lessons learned can you share about Bitmain on hydro and immersion? I'm keenly interested on this one, given I've been around for a while.
Okay, so I'm actually taking notes in my mind when they're talking, because we keep collecting feedback from our clients. So we truly believe that liquid cooling technology is the future of mining. And we also work closely with our clients. We see most of them have their pilot projects at least to try either hydro cooling or immersion cooling, or the other parts maybe we can talk later about it. So we feel that when we apply the new technology to a new field, mistake is inevitable, and what we're doing is trying to give our clients more guidance or support during the whole process. For example, now what we can support is for our clients, they are trying to do immersion just by putting the miners in the tank and with the liquid. So what we can do is we're helping them to off the fence or have a customized dashboard for them to make it easy, and that saves a lot of time and labor cost for them. This is the easier part, but for the other parts, we'll keep boosting the cooling technologies, we actually keep moving, improving the hydro cooling tower technologies, as well as the other parts. Like we're going to release the dry coolers to our client to ensure we are working together with them to avoid additional mistaken costs to be put in into their projects. And we are also happily to we're developing the next generation technology as well. When the time's there, we are happy to share to the entire market and moving the whole technology to another level.
No, I appreciate that. So, immersion, hydro, all these technologies are constantly evolving. Primarily, we're seeing single-phase type solutions for heat mitigation and thermal management. However, in HPC, especially with some of the more expensive silicon that's out there, we definitely see a lot of two-phase. Does the panel here think that two-phase will ever come back in style with the amount of silicon that we now have available? Paul, you want to take this one?
I feel so cold here. The air conditioning is much more powerful than single phase or two phase. So we did some tests 2 years ago for two phase immersion cooling, but finally we got the conclusion that the cost and not only for the equipment, the fluids, but also the long-term maintenance investment would be much higher than single-phase or hydro cooling. So we simply dropped off this routine. I mean, at the beginning we do both single-phase, two-phase. We have two teams working together, but two technology. And then after half a year R&D and testing, the problem is not from only the technology side. The heat dissipation will be much faster for two-phase, and because it doesn't need pumps, so it can save some cost from the pump side, but from the other side, the quality control, also the fluids, and the maintenance investment would be much higher. So from my point of view, two-phase won't be a choice for the mining industry. Maybe good for HPC, but not mining.
Yeah, so I think like as humans we chase efficiency. Like I think that's like a simple thing, right? In every industry. When it comes down to cooling a computer, two-phase immersion is the end-all be-all of cooling. If you ask any thermal engineer, that is simply just the most efficient way to cool a computer that we found as human beings, right?
Then ask the CFO.
Sorry?
Then ask the CFO, right?
Yeah. No, and to his point though, right, there's some drawbacks and there's some limitations on the technology as it is relatively new. To give some history, right, there is a couple companies in 2015 to 2018 that had massive two-phase deployments. 3M was in a different place, who's the normal fluid producer for this, and as the market kind of crashed off, that became less viable, right? But there's two things that are really important to the equation when you're doing an immersion deployment, or really just like any computer deployment in all, and that is like what the chip densities are, and then how much does it cost to cool it. So right now it doesn't make a lot of sense because the chip densities aren't there, and the fluid is $300 a gallon. Not to mention 3M has some PFAS issues and is going through some regulatory concerns, so they can't produce the fluid in a scale that really makes sense. On the other side of that, over the next 5 to 10 years, right, NVIDIA and Intel are already showing chips that this will make some people upset that simply won't work in single-phase immersion. It just, the thermodynamics aren't there. And if they're going that way, that means ultimately we're going to be going that way, right? So as we get smaller and smaller and smaller in density and you drive these things closer and closer together, you can start making up for the dollars per gallon, which is really the limitation of two-phase immersion cooling. So there are some companies out there like Solvay and a couple of stealth startups that I know of that are working on two-phase fluids. And if they can drive those fluids down into a reasonable cost point, I think two-phase will certainly make a big jump, right? Because we're going to be coming down and becoming more and more dense on our miners and our chips. On the other side, they're going to be racing to make this fluid that's cheaper and cheaper. And to put it in perspective, you guys, of how dense you can get with immersion, two-phase in particular, you could fit a whole megawatt right here in a very, very, very small tank. So, I mean, it allows us to build data centers that are, 1/10 the size and really build things in more innovative ways. I think it'll drive us moving away from the shoebox. I think it'll drive us away from the one controller for 3 hash cards model that everybody has. I think we'll start to see a lot of tank innovations where the tank is also the miner, right? One control card, backplanes, things like that, like a lot more technical innovation rather than just strip the fans off and dunk them in oil or strip the fans off and put a cold plate on them. So yeah, I definitely think it'll come back just because like as humans we chase efficiency, and from a science perspective, two-phase immersion cooling is the best way to cool computers.
That's a very clear opinion.
Yep. So it looks like Taylor and I are aligned again. So one thing that I've learned in this industry is that it's never enough, right? So when we started and we had gigahash miners to terahash, and eventually we're gonna continue to drive that north. And while I don't think two-phase is appropriate currently, eventually, because it's never enough and we're always chasing higher density, higher hash rate, higher ROI, we're gonna get there. It's just a matter of time.
Appreciate that. Irene?
So as a mining risk manufacturer, we always strive to bring the most advanced technology to our clients. We are trying to improve the per terahash of the miners, as always. And we think, liquid cooling is the great method for now to improve that. We are actually working on the two-phase immersion cooling solutions, but generally we don't disclose much until we official release it. But I do believe that it's definitely increase the density, of the mining, and it may be, like your question as a CFO, it may be costly on our one way, but with our efforts, I think we can help clients to make it as a very affordable and very professional and profitable solution for them.
Appreciate that. Yeah, ask any CFO and they'll tell you something can be either cheap, quick, or high quality. And as this technology continues to evolve, obviously we're going to see a lot more innovation. And that lends to the last question that we've got for the panel today. Are there any cutting-edge technologies in this space for immersion or hydro cooling that gets you excited, keeps you up at night thinking about how it's going to change how we actually mine over the next 2 to 5 years? Irene first.
So I think, from my perspective, and I worked for Bitman for 7 years, and our company really put a lot of efforts to ensure we always bring the best technology, the best efficiency miners to our clients. And since I came to this conference, and our CFO also come here, and he's trip to the States to meet a lot of our strategic partners. Everybody's asking the same question, what's the next generation of equipment? I think that's a very interesting thing to see the technology being improved for miners from generation to generations. And I'll keep it, until we announce it, and we're happy to share with you guys about our entire company's efforts on that. And I'm also excited about the technology improvement on liquid cooling systems. So we're going to have our conference in September in Hong Kong this year, and we will officially announce that too. Generally, we will have some really interesting be announced during the conference. So I hope I can accept and meet you guys in the Hong Kong conference and announce the exciting news to everyone. Thank you.
Okay, so being in mining for as long as we have, we got really used to manufacturers creating a new item, right? Whatever it is, new miner, new controller, new software, and they're like, oh, look at all this awesome shit that it does, and we pre-order it, right? We buy it and we get it, and it doesn't do any of that, right? So the efficiency's not there, or the quality wasn't there, and we just take it, right? It's been that way. This has been the way the industry is, and no, present company included. Anyways, we just got used to it. So we were sort of satisfied with the products we got. We ran them because we wanted to make Bitcoin. And in the end, they ROI'd in most cases. And we kept going. But one thing we're definitely excited about is that changed last week. So we deployed the first megawatt of hydro cooling by MicroBT and HeatCore in West Odessa, Texas, with a dry cooler, by the way. We ran at 114 Fahrenheit ambient temp. Our hashboard temps were 60 C. Our chip temps were in the low 90s, and that represents almost a 20% efficiency gain. So we're 20% cooler than the air-cooled units in Texas in full automation. It's really the first time that we've done a deployment where everything went exactly right. It was a breath of fresh air. So what I see is probably a lot like what Taylor sees, is you're going to see advanced mining where things are designed from the factory, set up, ready to go, and they just work. So if you look at an IBM data center or an AWS, when they order HPC, they plug it in and it works. That's what they expect, and that's what the manufacturers deliver. And that's the corner that we're turning now, and that's where we're heading.
Yeah, no, I think the thing I'm most excited about is that Bitmain's making an immersion miner. Been emailing them since 2016 for that, so that's pretty exciting to hear. But on the other side, the things that make me excited is seeing, what's miner, and then we have Chain Reaction, Aerodyne, all these companies coming to play, all with immersion miners ready. So I think that's super exciting. And then I don't know if it comes off of, like on the immersion side, but it's also cool to see all the firmwares getting unlocked, right? Like everybody's providing these scalable power deals, allowing you to control voltage and frequency. And I think some of that gets driven by wanting that unlocked on the immersion side, and that's kind of like trickling down. And I also think it's exciting to see this two-phase immersion thing come back to light. I spent 5 years working on it, and it's a huge passion of mine. And it's cool to see. Aerodyne's got something on their spec sheet for a two-phase immersion. Sounds like Bitmain's already working towards it, and I think that means Chain Reaction and What's Miner will probably follow along. But yeah, it's just cool to see people constantly innovating, and hopefully on the next bull run we'll get to see some really cool technology, advancements like we did from 15 to 17. I think that was the most exciting time in the industry, like at least for myself, watching those sites get built and like just being like a part of some of that stuff was really cool. So hopefully we'll get away from this shoebox in the oil, and we'll get back to building some really cool tech and pioneering off the backside of some of these HPC guys like Google and Microsoft, and following what they're doing. Obviously a lot bigger R&D budgets that we can learn from. Had some time to get to spend some time with Christian Blotti from the Microsoft team and like see how much goes into the backside of their data center. So yeah, we'll definitely keep our eyes and ears open to what the next innovations are, but it's cool to see that people are already kind of opening up and unlocking the things that we need to be successful.
Paul?
I think there are a lot of cutting-edge technologies, not only from the machine side, but also from the chip side, like how to improve the packaging of the chip from the die, because the heat dissipation, there are several layers. I mean, from the die to the external dry cooler, there are a lot of layers. I was a professor in a university before last year. I work with in my lab, and currently we also have the joint labs with universities. There are a lot of new technologies, but most of them are not ready for mass production. There are no mature supply chain. So that needs much more time than just technology, R&D. Last year we worked with Intel for about half a year before they shutting down this business of block scale. We have many conversations about how to utilize the technologies, state-of-the-art technologies. But finally, what we really did is single-phase immersion cooling, not the newer ones. I mean, yeah, but I'm open to all possibilities in the future. You see, there are some advanced technologies from the HPC area, like one. They did a very big chip for the AI computing, from my point of view, actually, the mining chips, the density of mining chips is actually the thermal density is lower than GPUs, CPUs, but the total density, thermal density of the whole machine is higher. So the characteristics are different from data center, from the servers, traditional servers. So we have to select maybe not the most advanced technology, but the most suitable technology to serve this industry. Yeah, that's my point of view. Thank you.
No, I appreciate that, Paul. Your insight into the actual science of the technology is very enlightening. Appreciate it. We've got a couple of minutes for questions from the audience. If we can get a microphone to the audience, that would be great. So if anyone's got any questions for the panel, happy to field it. Otherwise, we all go get coffee. Well, appreciate the time. We got
some runtime, so let's get some questions in.
Okay, well, anybody have some questions from the audience for the panel? Mike, you got one?
So talking about immersion, I mean, you guys covered almost everything. Is there any like high-level wishes of like attaining some sort of like futuristic hardware where immersion would be something that would be built into the fabrication of the chip, being part of the encapsulated aspect of immersion, being part of that architecture from inception? Meaning, when you make a chip, you obviously know that it's going to get hot. It's through its lifetime. That's just part of the DNA of a chip. But because immersion is such a dynamic medium, is there high-level goals of what immersion could become in the next 10 years? How does that integrate at the chip level, where instead of having a tank and having the components dunked into it, how this can, hypotheticals here, like, high level, 10 years down the line, what do you guys think?
I'd love to take this one. I mean, I think Paul mentioned something that's really interesting to me is that integration of what we're doing with digital mining will continue to evolve. There have been use cases of using the heat for wood curing or food desiccation. In some Scandinavian countries, they're actually using the heat for distributed water heating. I think that as we continue to evolve as an industry and it becomes more accepted, the heat will not be viewed as effluent, but actually used as a resource. So being able to build immersion tanks and technologies and facilities into where they actually need heat for greenhouses, for everything else, I think that is something that we'll probably be seeing a lot more with innovation and governments actually supporting the excess heat that we generate as we generate hash rate for benefit of the communities that we operate in.
into your question on what can we do different on like the chips and the boards, right? So like on the Immersion, you can package the boards to be a lot closer together. You can lay things out to where you're worrying about fluid flow rather than airflow, which is a little bit different. And then at the actual chip level, we experimented with some cool stuff where you're actually putting a boilerplate, which is basically copper and silver melted together under pressure. It creates a bunch of ridges and valleys. It expands the surface area of the chip. And instead of having these big boilerplates over chips, which is how two-phase immersion works now to spread the heat, actually building those into the chips themselves, like on the top of the packaging. So I definitely think there's some people out there that can really get innovative. It sounds like he might have some ideas on how we can not only develop the machines to be denser and better designed for immersion, but actually at the chip level taking advantage of reduction in parts and things like that. And yeah, there's definitely some ways that you can make some advancements in immersion and making the chips function better.
Not really much to add on after Taylor, but he's absolutely right. You can, from the PCB side, you could design the board so that you pack more chips onto the PCB, so you get a higher chip density on the board. Wouldn't run in air because it would overheat immediately, but it would be specifically designed for immersion, so that could increase our density. Really what it comes down to is the sky's the limit. If we can dream it, we can make it.
Yeah, double-sided boards as well is also like a cool idea, having chips on both sides, like Avalon's, the 841s back in the day, the aluminum hash cards, you could use those as like a heat sink to pull heat from the back. Yeah, it's really interesting, like when you think about, like I was trying to explain it, if you have a pot of water boiling on the stove, you stick your hand in it, you're driving to the hospital within seconds, right? It's a horrible. If you have an oven open, you stick your hand in at 400 F, as long as you don't touch anything, you can pull it out. That's what's happening to your miners in air versus like immersion. Like that's a different capability. That much heat transfer is something that we can definitely innovate on as humans.
Paul, any feedback on that question?
I think in the future, it does not have to be immersion cooling like today. To combine with some improvement from the chip side, maybe, I mean, in the long term, maybe 10 to 20 years, you can combine immersion cooling with some other technologies from the packaging of the chips, as I mentioned. So, yeah, I'm sorry, because it's too cold. So what's your original question?
Well, yeah, I mean, I think that my original question was more like futuristic, not like the next 2 years. I'm talking next 10 years of the cooling technology for immersion. But I guess I could rephrase the question since we still got runtime. We got like 18 minutes left. And I'd like to invite the audience to come up with cool questions. I mean, there's no stupid questions. Like, you can get silly and ask questions, but they're all valid. But anyways, I guess I could rephrase the question a little differently. What about hydro versus immersion? Like, I think Bitmain could be a great question would be more for Bitmain, since you guys have that great hydro technology built into the miners. What made you decide that hydro was going to be the choice for the medium of cooling the miners versus immersion? And with that being asked, what are the advantages of going hydro versus immersion? And if there is, if you're working on immersion, because I heard TK say that you guys are coming out with an immersion miner, what are your opinions now that you have both? Which one is better?
Thank you. So the reason we start to develop and have the hydro cooling miners and solutions to the markets is because we think hydro cooling method can maximum, boost the chip's performance. Because we are, as I said several times, we are strive to bring the most advanced technology and best efficiency mining rates to the market. And that's the main reason we choose this. During the whole process, we actually make a lot of improvements on the solutions and to educate the market how to work with it, and as well as collecting feedback from the market and see what we can better support their projects, because every client have different size across the world with different conditions. So we're trying to develop the technology that can help them to work in different locations in different seasons. So that's the main reason we use hydro, and we are, we have different kind of choices of coolers, like the water cooling tower and the dry cooler. That's also, part of works has been made because we collect the feedback from our clients for them to have easy deployment solutions in their countries and their policies. So, and we also see our clients developing Immersion cooling system, because from their development strategy, they want that be their kind of like strategic power to be outstanding companies among their peers. So that's very reasonable, and we are supporting them because we would like to see, we can help from the manufacturer level. That's the reason we support this technology, because we have to learn it, and we want to see if we can do something better, because we really have a large group of engineers and developers with a really abundant experience. So why not take advantage of that? As you'll see, people have difficulties throughout the process of developing infrastructures. That's the most difficult part around the world. And we just want to make things easier with the technologies, the experience, and everything in our hand to make the industry easier.
Mike, I'm going to tag onto that real quick. It's hard to pick a clear winner. You'll have people from both camps, hydro and immersion, that think one might be better than the other. But in terms of cooling capacity and efficiency and improvements in the overall operation of mining sites, I think you're going to be hard pressed to find material differences. You've got higher capex versus air cooled, similar capex compared hydro to immersion. When it comes to ease of deployment and installation, I think that we have to kick back to the manufacturers, right? So the products as they come should be ready to bolt on and fire up. And that's we jumped into the hydro camp. We've experimented and done a lot of R&D with both. And we believe that the current state of the market, the hydro units offer the clients faster uptime, faster time from writing the check to deployment and getting the units up and running. But again, it's Ford and Chevy. It's really hard to pick a clear winner.
Can I add one more? Because everybody's talking about the ROI on infrastructure or the investment on the system. So there's one advantage of the hydro cooling system is really affordable. And I was mentioned that we're trying to dramatically decrease the infrastructure costs of the entire mining business, and that's also one of the reasons we have this technology and product. Even it's very comparable. Even you can say that the air cool infrastructure, and on the other hand, we support clients to build their mining infrastructures with multiple, business models. For example, if they are happily to try with the hydro solutions, we can work with them. And if they can't find customers, we can be their customers. We can help them to develop the projects and take the hosting space. And we may help them to, we might sell the on-rack miners to the other clients to help those people with limited ability to set up a large-scale mining projects to have a decent mining experience, and also be helpful for clients, for more people to have their a rather comfortable mining experience.
Paul?
I think the answer is maybe simple. If you ask a hydro cooling manufacturer, yeah, he will say hydro cooling is better. But if it's an immersion cooling guy, he will say immersion cooling is better. But from my point of view, as a strategic technology partner of MicroBT, we do both. And I think both of them, either of them, has pros and cons. For immersion cooling, I think it's more mature than hydro cooling because hydro cooling, we have not enough time to do the long-term test. I mean, for the whole industry, we have no more than 2 year experience to do the long-term testing. So even between, I think. So for the real case, for the real deployment, but immersion cooling has much longer history. But I think hydro cooling is also good for its easier deployment. But there is a precondition that you have to plan it more seriously than immersion cooling because it's really not easy to modify after you did the deployment, and because the hydro cooling does not isolate the air from the dashboard, from the PCBs, and if you obviously use water inside, there will have some risk on the leakage problem, more serious than immersion cooling. So as we work on both of them, I think either has a long way to go to become real mature for the industry to for the mass adoption. So yeah, that is my comments.
Yeah, let's not forget the S9 Hydro way back in the day. So it's been more than a few years on the Hydro technology. But Mike,
But S9 Hydro, it's yeah, the scale problem, very serious.
Very serious. Yeah, I mean, the hydro versus immersion, from what I've seen on the deployments that we've been part of, I mean, it really is based on the environment and the characteristics of the site you're working on. One thing that wasn't mentioned is that immersion fluid can be potentially an environmental concern, depending on the type you're using, where water, if it spills, it doesn't really matter. On the opposite side, high PSI with electronics, as some experienced way back in the day, is not ideal. Whereas immersion, it's very clean. There's no risk with electric shock through the dielectric. So there's pros and cons to each different type of technology for sure. So I think we've got one more question from the audience. We got one in the back there in the pink shirt. Appreciate that.
Hey guys, question. So with hydro, is there a way that you could have a hybrid system of sorts and share the fluid from liquid immersion to hydro miners to prevent any type of conductivity?
Yeah, so you can definitely use dielectric fluids to liquid to chip. There's a lot of companies using two-phase fluids, for example, for direct liquid chip. Yeah, if you do some digging, like in the regular data center industry, we call it hydro. It's really called liquid to chip. There's tens to hundreds of megawatts of different versions of liquid to chip deployed all around the world. Some use water, some use some sort of dielectric fluid, and you can definitely do that.
I think that the big standoff there is price, right? So you can get deionized water fairly cheap, and you're not going to get a huge benefit other than if your primary concern is leakage or condensate on the PCB would be the only real driving force to say, hey, I'm going to use a dielectric fluid. Your cost for the fluid is going to go crazy because you're about 750 gallons for a hydro, like a 1 meg hydro solution, and that's the guys from Engineered Fluids will love you. But yeah, it's going to be a lot of money.
Follow up to that, how often does the water evaporate, and how often am I replacing the DI water?
The short answer is you're not unless you get a leak, which is awesome. So on the dry cooler system, it's a sealed, lossless system. The whole thing's stainless steel. So once you seal it and you lock down the butterfly clamps on the tanks, there's no loss whatsoever. So if you were geographically wherever you're located, you're going to change your mix from DI, water, and ethylene glycol, and maybe an extra rust inhibitor. So if you're in northern Texas and you're like, holy crap, we're going to have another winter storm where it's going to be 0 and it's never 0 here, and you went 10%, you're going to need to go 20, 25%. So that's really the only changes you'll ever need to make when you've got a lossless system.
North of the wall, you definitely need glycol in that fluid for the winter, that's for sure. So really appreciate the panel's time. We've learned a little bit about the ongoing evolution of immersion and hydro, 75% potential reduction in OpEx, really stabilizing your hash rate performance, and really optimizing what you can do in a smaller space. I really appreciate the panel's time, and thank you for listening. Hope you guys found it interesting. Thank you.